An introduction to parametric equations. A curve can be defined in terms of its Cartesian form, where you have any arrangement of x and y terms, but there are two variables, x and y, and only one equation. An alternative is the parametric form, where we have two equations, we have three variables, we have x, y, and the third variable, t, which is called the parameter, hence parametric equations. So we have a separate equation to work out x coordinates and a separate equation to work out y coordinates. But they are both given in terms of t. This is a useful format when we are curve tracing and we're looking at the position of a particle at a given time. Here is a basic example demonstrating parametric equations. So we have two equations, both given in terms of the parameter t. Now we need some values for t in here. And in this example, t is in this interval between -3 and 3. We're going to work out x and y values from these equations and then plot points on a graph. So when t equals -3, so x will be -3 squared, which is 9, -1, 8. Y will be 2 times -3, -6. T equals -2. -2 squared is 4, -1, 3. 2 times -2, -4. And we complete the table. And then we plot these points. So the first point will be this. When x is 8, y is -6. So what we have here are coordinates. So here is the first point plotted, and I've written down the value of t that it corresponds to. So t is equal to -3. Second point, t equals -2, so we're doing this one. X is 3, y is -4, x is 3, y is -4, and we write down t equals -2. Now we can join these together, like so. So as t increases, a particle has moved from this point to this point. So we're tracing out the path the particle has taken. And then t equals -1. A particle is now here, and so on. So as t increases, a particle moves in this direction along this path. Moving on to domain and range. Now for this graph and for these values of t, the domain will be the set of values of x for which this graph is valid. So the values of x from here to here. For example, x equals -2 would not be a part of the domain. -2 is here. There's no graph at x equals -2. -1 is valid. When t equals 0, x is equal to -1. That's a valid point. But t equals 3 is not included in this. It says t is less than 3. So t equals 3 is not included. So for that reason, x equals 8 will not be included as part of the domain. So the domain is any value of x starting from x equals -1 all the way up to, but not including, x equals 8. Now the range is the set of values of y which are valid for this graph. So it appears as though it's between 6 and -6, but again remember, y equals 6 corresponds to t equals 3. We can't have 3. And y equals -6 corresponds to t equals -3. And we can't have t equals -. It says t is greater than -3. So the 6 and the -6 are not included. So the values of y in the range are these. Okay, I'm going to modify the set of values that t can take. So I need to change everything in here. I need to change the table of values and the graph. So t is greater than or equal to 0, so these negative values of t are no longer valid, so I've got rid of those, which means I need to get rid of these negative values of t along here, so this portion of the graph has to go. So now we have this. So t now goes from 0, so starting from 0, and it will go to infinity. So x can take any value starting from -1, and then it goes on to infinity, so we have x greater than or equal to -1. And because the graph doesn't stop at this point, it continues forever, then the range, or the values of y which are valid, so y greater than or equal to 0. Now sometimes we want to change our parametric equations back to equivalent Cartesian form. So for the parametric equations here, if I take y equals 2t and rearrange to make t the subject, and then I'm going to substitute this into here, like so, I have now eliminated the parameter t. So this is a Cartesian equation. You can simplify this, but we do have a Cartesian equation right here because the parameter t has been successfully eliminated. We don't have to write this as y is equal to. This is perfectly fine for the Cartesian equation. So for t in this interval, again, where on the curve is x equal to 3.5? So I need to work out the value of the parameters at x equals 3.5 and y coordinates. So we start off with the equation for x. I know x is equal to 3.5. We substitute that in. We solve, we square root to get plus or minus, so we have two solutions, and then we substitute these two values of t, these two values, into the equation for y. So y equals 2 times t, y equals 2 times t, to get y coordinates. So we have coordinates for 2 points. So these are the two corresponding values of t, giving these y coordinates.